The multi-set API adds only 5 methods on top of what's already in the collection interface. And these are methods that are designed to do the sorts of things that you typically do when you use a multi-set. So very common thing, you want to know how many occurrences of a particular element are in there. So that method's called count. You may want to add a whole bunch of occurrences at the same time or remove a bunch of occurrences at the same time. And you may also want to directly, say, okay, I don't know how many I'm adding or removing. I just want you to make the count this value. So in multiset terminology, if you add the letter A to your multiset 3 times, we call that 3 occurrences of A. And the total number of occurrences of A is called the count of A. Those are the terms we adopted. We could also say frequency and multiplicity, but we just don't use those in this doc. So you could directly set the count to a new value, or you could say conditionally set the count to a new value only if its current count is the old value. Once you have these methods, then these are actually suitable for use in concurrent applications. These provide you the ability to do atomic operations without needing a special concurrent multi-set interface, because in this case, the base interface simply has all the methods that you need. In retrospect, java.util.map might have also had all of those methods, but that was a long time ago. We learned things since then. That's okay, and then we have, oh my God, we have 6 implementations of multiset in our library. Although, most of them share a lot of code. First and foremost is immutable multiset. We also have immutables for all of our own collection types. And then, if you want, the main question is, since multiset tracks duplicate, the count of occurrences of a particular element, you have to think about how do you want it to decide whether element A and element B are really the same. If you want it to use hash code and equals, that's a hash multiset. If you want it to use a comparator, that's tree multiset. And that also has the effect of sorting all of the values. And if your elements are enums, you may as well use enum multiset because that'll be faster and simpler. And there's the concurrent multiset I told you about. Any questions about multisets? Okay. Yes? You can always, the question is, can you transform a immutable
or make a copy thereof
into a mutable? And that's simply a copy operation. So every mutable collection is usually going to have a copy constructor or a static factory method that serves as a copy constructor. In the JDK collections, they're constructors that take collection. In our library, we have static methods that take iterable, but the concept is the same.
But just to follow up, if you have...
He's following. Just put it up to your mouth.
Oh, if you have in the immutable case, once you've created a collection that is immutable to begin with, you can exploit some extra data structuring underneath, perhaps, to take advantage of the fact that there will be no more inserts into it.
Right.
So do you do anything? Can you talk about that?
So in the immutable collections, it's very... we know up front what the exact size is going to be. So we can size the data structure, and we don't have to have any of that logic for providing for resize operations at all. The other thing that's nice is, in certain cases, like an immutable set, we can actually, the first time that someone calculates the hash code of the set, this is getting a little esoteric because most people don't call hash code on their sets very often, but the hash code of a set is defined as the sum of the hash codes of all the elements. Once we do that once, we can just simply cache that result. And we don't have to keep doing it over and over. And that means if we're testing 2 immutable sets for equality, we can first check their hash codes, and it's really, really fast if they're not equal.
What about also the queries, the individual queries into a set or an immutable set or an immutable map? You can optimize the data structure inside to say each query itself can be pretty fast.
Well, I suppose what we should do is, like when you get out of here, you could go look at our code. And or if we have a laptop, we can look at it together after the talk, and we'll sort of look at how we do. I don't know if I could talk through it off the top of my head, but there's certainly a lot of corners that we were able to cut because of the immutability situation.
What about testing with JSTL? Because like I see, like with the count, you mentioned you didn't do a get count and things like that, and that's going to require a key to look up. Has any testing been done there If I was to...
I don't know what JSTL is.
Okay.
Do you want to tell us about it, or is it... We can talk later. I'm sorry. Bad me. Gentleman in the front row is beginning to become something of a pest.
I'll shut up if you want.
No, that's
but
okay.
I wanted to make a very minor point, which is that what you referred to as copy constructor. I apologize. I really think I used the term wrong in the first edition of Effective Java. So in the second edition of Effective Java, I call them conversion constructors.
Okay. Conversion constructors.
Because you're picking the type of the thing that you're creating.
Okay. I'm going to try to go a little bit faster, but not much. So now we move on from multisets to multimaps. So how many times have you ended up writing code like this, where you have a map from some key to some collection of values, and you're trying to basically store a many-to-many relationship? In this case, we have salespeople and sales, and we want to build up a map that will let us find all of the sales corresponding to a particular salesperson. And this is the current way of doing it without the benefit of libraries like ours. Each time that you make a new sale that needs to be added, you've got to find out whether you already have a list stored in this map for that key. And if you do, you can just add to it. And if you don't, you've got to create one and add it yourself. So this is pretty much an idiom, and once you've encountered it once, you can sort of do the same thing from time to time, and it's not that bad. But let's look further. Would you rather do this? In this case, we create what we call a multimap. Okay, we're not the only ones who call it a multimap. You can look it up on Wikipedia. Everyone calls it a multimap. From salesperson to sale, and this time the implementation of our method is simply put. That's all we have to do. And under the covers, it will do all this ugly stuff for us. The benefits of this are pretty clear, and they're similar to the benefits of the multi-set. The code has become a lot less verbose and bug-prone. It also offers, this is another, returning to what I was emphasizing before, it means that as you start to need more and more complicated things, the library is ready to give you those things. You don't have to go and write all that code to do those things again. And here's this is not an example. Okay, first I'm going to, yes, question.
This is one many, not many to many.
Well, it's,
one salesman has multiple.
It's many to many in the sense, okay, it's not bidirectional many to many, but the same key can have multiple values, and the same value can have multiple keys as before. So you could say that in this terminology, you could say a regular map is many to one, right? Because you could have distinct keys with the same value. But it's not bidirectional. You can't navigate it backward in that direction. Am I making any sense? Okay.
Not sure.
Suffice it to say, here's what a multimap is. It's a collection of key value pairs, just like a map, except that keys don't have to be unique in this collection of key value pairs. So you could have A equals 1, A equals 2, and then B equals 3, and then you could have a bunch of values for C. And now I see a lot of hands up, so let's start over here. Do you want to find a microphone?
So in all the examples that you have shown, you've basically been using the factory method to create any of your collections, but
right.
You are not using the constructors anywhere. Right. Is there any particular reason, or you don't have the public constructors at all?
Constructors are basically pains in the... Can I say asses? I think I just did. Constructors really are a big pain. The main reason, the most immediately apparent reason, is that Java-C does not have type inference for the generic type parameters of the constructor. So as long as you're calling constructors, you always have to do really ugly stuff like this. All these type parameters on your type variable here have to be repeated word for word on the constructor. There is absolutely nothing else that you could put in between these angle brackets. It has to be exactly this or it won't compile, yet Java-C makes you specify it anyway.
But do you have the public constructors in your collection?
Do we have public constructors? We do have public no-argument constructors, but we don't go and provide all the same convenient overloads in the constructors as we do in the static. And in fact, if you look in, I think it's section 1 of effective Java that says prefer or consider static factory methods, and there's a lot of advantages in there to static factory methods that we agree with. Other question? Or maybe, okay.
Is there any provision for going multiple levels deep on those lists? Because I've sometimes had to create a list of something.
I don't think we have anything that specifically addresses that right now. Like basically a map from a key to a map from another key to a value, and sort of multi-level things like that, or lists of lists.
Well, yeah, like a map from a key to a list of something.
Oh, okay. No, I don't think we have anything like that right now. We just sort of work in order of, the volume of code that needs, the method. And I don't think we've gotten around to that yet. So in this case, yeah, all right.
Just one question about multimaps. What will return method get if no any elements for key?
Oh, yes. So anytime. So
null or empty collection?
Very good question, and I believe that question has a right answer and a wrong answer. Multimap get key returns a modifiable collection view of the values associated with that key. Therefore, if there are no values, you get an empty collection. We're not going to just return null. And in fact, this is a live view, so even if it's empty, you can insert an element into it, and that will cause the corresponding entry to appear in the multimap. So this is a very powerful thing about Multimap, is it supports lots of view collections that allow you to look at the data in many different ways, and this is one of them. So sometimes you want to think of your multimap in these sort of terms. So for example, like if you do web programming, you know that URL query strings can look like this, like I've described. You can have the same key appearing multiple times. And so we have a URI or URL class that actually uses Multimap to represent the query parameters. But sometimes you'd actually rather think of it this way below, where you have a single key and then the collection of all the values that map to it. So if you want to look at it this way with an as-map view that you call on the multimap, and now you can look at it in this way. There are a few subtypes of multimap. So right here I said that get on a key returns you a view of all the values that correspond to that key. And that view is a collection, but different multimaps will have different behavior to that collection. So the names that we're using for these types are list multimap and set multimap, because in list multimap, the collection of values corresponding to a key implements the list interface. And in set multimap, it implements the set interface. So you get the behaviors that this implies. For example, in a set multimap, you're never going to have duplicate entries. You couldn't have duplicate entries because then the value collection corresponding to a key would not be a set anymore. So we have list multimap, set multimap, and sorted set multimap. And there could be others. At this point, you might be thinking, it sort of sounds like we've come full circle, and you just basically have a map from key to a collection of values. So you could almost have just stuck with the original code. But now I'm about to kick it up a notch. Let's go back to our salesperson and sale example. Now we want to find the largest sale. That's it. We got to write all that code. So we have this data structure that maps salespersons to sales. And we just want to find the biggest one. And look at what we had to do. This should make your blood boil, right? When you see this, you should think, you know how some people are always saying, there ought to be a law. So when you see this, you should think there ought to be a library. And you should expect to find that library somewhere, hopefully. And in this case, it's our library. What did we have to do? We had to loop through each of the lists that were stored in the map. We have to find the max sale in that list, and then compare it to our previous max sale, and close all these loops and then return it. Or we could have built up a temporary collection, and then for each list, put the biggest in the temporary collection, and then call max on the temporary collection. But what would this look like with a multimap? It looks like that. One line of code. The reason it's so simple is that the multimap has all kinds of view collections that let you view the data in different ways. And when you can view data as a collection, then you can take advantage of all the many utilities that have been already built to deal with collections. So collections.max expects a collection, so we use the multimap.values view, which feeds it all the values across all the keys, and it just pulls out the largest one. So
Where's the comparator?
where's that comparator defined?
To be fair, you should include
It could be anything, though. So the comparator is the same in both examples. So I use it in this example here, and I use it in this example. So, what it probably does is it takes a sale, and it calls the .getCharge method on that sale, and then it does the same thing to the other sale and compares the charge values. But it's not really relevant to the A versus B comparison here.
I'm sorry, I withdraw the question.
Yeah. Cool. Phew, he withdrew the question.
If only I could go back in time.
Okay. So yeah, the point of this is we love view collections. They're very, very powerful. They allow you to magnify, to multiply the total number of different things you can do. Is there a question? Yes. Microphone.
So now that you get your biggest sale, how do you get to the salesman who made that sale?
Well, this example isn't doing that.
Okay.
So what did you say? You withdrew the question? I withdraw the answer. Different slide, different day.
So couldn't you just use the same technique with a different comparator and view the thing, taking the appropriate view, which preserves.
Yes. Here's what we would do.
Yeah,
Instead of taking the
absolutely.
values view, we would take the entries view.
Absolutely.
Entries is a view containing map.entry objects, which are the same type that you have in a regular map, because all they do is they consist of key and value. And you'd find the max entry from that, and then you could navigate from there to both the. Thank you, you saved me. I unwithdraw my answer.
This approach basically blows out the entire set of values.
The mic.
Right? It blows up the entire set of values into one
You're a
list.
rock star.
Okay, I can also just repeat the question. That's fine too.
It just expands the whole set of values into one list. So if you've got a map that's got lots of values in it, it can use up a lot of memory.
No,
Or-
actually.
No?
So this values is simply returning to you a view upon all those values. It's not actually copying all of that data into another structure. It's simply a custom implementation, and this is why we have Jared, or Jared
Okay.
because he masterminded doing this kind of
Okay,
crazy
okay.
stuff.
This sounds much cooler than I thought.
Yes, that's if there's one takeaway I would like everyone to have from this presentation, could you repeat that?
I guess
I think it's much cooler.
It sounds
than I
much
thought.
cooler than I thought.
That's good. That's how I feel. Okay, so I was supposed to pick up the speed a little. Most of the methods on Multimap are really just very parallel to the same methods on Map. And if you can imagine going back in time with all this being in the JDK, these could have implemented a common interface because they behave exactly the same. Other ones look a little bit different. For example, the get method, instead of returning a V, it returns a collection of V. And we have a couple of different remove methods, one to remove a particular entry and another to remove all of the values for an entry. And so on and so forth. I'm going to gloss over that a little bit. And there's a few new things, too. It's very full-featured. And we have 5 implementations so far. Okay, that's it for multimaps. I'm going to start now doing more of a rapid fire over some of the other types because they're a little bit less ubiquitously, a little less popular than the first two, I guess. Question?
Concurrent multimap.
Oh, yeah. So concurrent multimap is in experimental stage right now. We're still going back and forth on a few of the design issues, or we're sort of letting it build up some usages internally first, and we may end up promoting it into the external library,
So
hopefully.
No theoretical reason.
I'm sorry?
No theoretical reason for omitting it.
Yeah. Theoretically, it works, and it appears to work in practice. So a bimap, also known as a unique valued map, is just a map where all the values are unique. So this is good for, first of all, if you just want the extra checking. If you're building up a map and you know the values are supposed to be unique, go ahead and use a bimap, and that way it'll blow up if those aren't unique, at the expense of the extra memory that a bimap does require. The coolest thing about a bimap is that because the values are unique, it has an inverse view, which is also another instance of bimap. You can view that same bimap in either direction, and if you take the inverse of the inverse, you get right back where you started again. So I'm sure that many times you've had data that you populated in a forward map and a backward map separately. You can keep doing that if you want, or you can just let us do it for you. That's basically what this interface amounts to. We'll take care of making absolutely sure that those two stay in sync, even in the face of all kinds of mutation that they could be undergoing. And there's a few implementations of this too. ReferenceMap, this is not a new type. It implements concurrent map, which is an existing type. And if you have never used weak references or soft references, first of all, you're lucky. That's great. If you never have to deal with them, I kind of wish I was in those shoes. But if you aren't familiar with them, you can take a snooze. If you are familiar with them, then you know about weak hash map in the JDK. It supports weak keys with strong values? All right, Josh. But there's really 9 different combinations that you could want. You might want any of strong references, weak references, or soft references for your keys, and strong, soft, or weak for your values. So there are 9 possible combinations. Of course, if your combination is strong and strong, then you wouldn't be using this anyway. You would just be using a regular hash map. In addition to this, it fully implements the concurrent map interface, and it is a fully concurrent data structure. And it has to be because cleanup of these stale references is happening in the GC thread. So as long as we were following that strategy anyway, we went ahead and exposed this concurrent behavior fully in the API to you. Josh.
One last question, I promise. So those idiots who wrote weak hash map really got the identity semantics all wrong. It uses equality rather than identity, but it only makes sense when equality and identity are one and the same.
Right.
So did you smart folks, fix this up in any way?
Yes. So rather than going to idiots, I went to Crazy Bob, and so Crazy Bob implemented this, and yes, he does the right thing. With weak references and soft references, it's always identity semantics. With strong references, currently it's always equality semantics, but we have considered the idea of adding a 4th option, which is strong with identity. So you'd have soft, weak, and then strong identity and strong the other one. But we haven't done that. I felt compelled to point out that it is not yet as fast as it could be. If the code ever becomes imported into the JDK such that it has access to some of the package private internals of java.util, we can make it faster. We could also make it faster if we were really willing to do some really, really ugly stuff with the code. And we might have to resort to that one day. But for now, we're using it in production, and it's fast enough, so we're not worried.
You have a lot of computers to run it on.
Yes, we do. We do have a couple computers to run it on. That's true. So this is sort of unique among our collections in that if you need to do what it does, it's just really, really hard to do it any other way.
Could you give us one example of where this gets used within Google?
Okay,
if
so
it's used proprietary.
It's used a lot for caching. Yeah. Say that you have a customer object and you want to cache in memory this whole list of transactions. But what you want is for when that customer gets garbage collected, you want that customer, you don't want to prevent that customer from being garbage collected. And if you just use strong references in your cache, now you're in a hold on to this customer forever. Actually, as a business, we do want to hold on to our customers forever. But in our code, we like them to get cleaned up. So the weak reference will not prevent garbage collection. And when garbage collection does happen, the entry will just get removed from the map automatically. Okay. Switching gears, we have a class called ordering. It's starting to get to the part of the talk where I'm just going to skip from random thing to random thing. in the JDK, you probably know the interface comparator. And it's used for comparing things and deciding which one's less than the other, or if they're equal. And this is an interface with one method, and so it's very easy to implement, but it's a pain to use. Usually there's a trade-off there, and the designers, rightly so, decided to focus on ease of implementation because you tend to implement these things a lot. What we have done is created a class which we've had to call ordering, which really is a richer version of the comparator. And what you do is you take your existing comparator. So here's a comparator that exists in the JDK, string.case-insensitive order. It's a comparator that compares strings ignoring case. And you can call ordering.forComparator, and you get the ordering instance that corresponds to that same comparator. Now, this ordering also implements comparator, so you can use it as comparator, but it has a whole bunch of tasty methods on it also, like min, max, is increasing, sorted copy of an iterable. You can also call .reverse on it. Now you have another ordering that is just the reverse semantics to the original one. So this is a slightly more OO way to provide all of these utilities. Instead of just having a long list of static methods that take these iterables and comparators passed in, we let you turn that comparator into a richer version of itself. We let you upgrade your comparator to a super comparator. And then you can do all this fun stuff much more naturally and object-oriented in a way. I'm going to move on to covering some of our static utilities. Static factory methods, we has them. We do this for all of our collections. We touched on this earlier. We don't want you to have to type all of this garbage in your code. Garbage belongs in the garbage collector, not in your code. So things like this are just tremendously sad, and it's more sad to the people who worked on generics in the language than anybody else. It's like there's real weeping that happens over this. I've seen it. And we'd very much like this to be fixed in the language in the future, so that you did not have to redundantly specify all this stuff. But our library is about what you can do today, so we make sure to provide you a static method. It just happens that in Java, static methods have excellent type inference, and so you don't have to go and repeat those parameters except in a minority of edge cases. In fact, this is so nice that we also provide this whole litany of static factory methods for JDK collections as well. And we put them in classes called lists, sets, and maps. These are actually by far the most popular thing in our whole library. They're one-liner implementations. They do absolutely nothing, but they make your code cleaner, and that's really important to us. We want your code to be clean. We want it to be very readable. And this is something that if you, for whatever reason, don't use our library, but you are using Java 5, you should at least open up these files and paste all that source code into some class in your own project, so that you can call these methods, because it's just, this stuff is just such noise. But that in itself might not be enough for you to motivate you to use our entire library, but you can at least steal that stuff from it. I wanted to talk for a few minutes about working with iterators and iterables. This is another big area of support in our library. It's something that we tend to treat iterators and iterables as first-class citizens a little more than the JDK library does, and it's a constant source of friction between me and my office mate here. In our opinion, collection is a really good abstraction to be working at when all of your data is in memory. If all of your data is not in memory, like you're reading it from a file or whatnot, and you want to make a single pass through it, you can implement collection, and that can be all right sometimes, but it tends to be more cumbersome than is always necessary. And when you're all done with all that cumbersome stuff, you're going to end up with a collection that may be sort of badly behaved. People may take that collection and just call .size on it, and they may not realize that that's going to cause your collection to go and slurp the entire data stream out of a big table or what have you. So we tend to focus on iterator and iterable. If that's all our method needs you to give us, that's all we ask for. We don't make you pass as a collection. As well, we also have classes called iterators and iterables that are full of useful utilities for working with these things. So these are parallel structure. The exact same methods appear in iterators class that take iterator parameters and iterables class that take iterable parameters, except for the ones that don't make sense in one or the other. And they let you do things like, I've omitted some of the generics from here because it was too verbose for my slides. But you can transform, you can pass all the elements of one iterable through a function to get another iterable. You can filter based on a predicate, and a whole bunch of other methods with predicates like find, any, all, and so forth. You can concatenate an iterable of iterables. So if you have a whole bunch, so we were talking about lists of lists. If you have a list of lists or something like that, and you want to view them all as a flattened list, you can use this method. You can get an iterable that cycles over a source iterable infinitely, things like that. The thing that all these methods have in common is that they're absolutely as lazy as possible. Because I wrote them, and I'm absolutely as lazy as possible. So they will never access the backing iterator or iterable until they have to. So this will be familiar to many devotees of functional programming languages. It's a really good thing when you have a lot of data to process. You can set up a whole, you can concatenate these things and then filter them and transform them. And then only as you start to access the data will it actually turn all of these gears and actually go through and read all of the input. It needs to be said that having interfaces called function and predicate and having methods to transform and filter them based on them does not exactly make Java into a wonderful functional programming language. So if you love functional programming, and a lot of people do for very good reasons, and you'd love to be able to do FP in Java, you can do it, but it's going to be ugly. And I would say in many of the cases where people have started using these APIs, in some cases it's a net win, and in some cases it's actually a net loss. Sometimes their code ends up just being more confusing and filled with more generic type parameters and inner classes and jumble than it was before. Java as a language right now isn't really set up to do FP that well. The reason that these methods exist is because sometimes they're just what you need. And when they are just what you need, you should use them. But if you do use them, take a look when you're all done, if you really like the way that your code came out. Because you may find that in some cases you would have been better off just doing things the old-fashioned way. And that's my spiel about that. Questions? Nobody wants to take me to task about FP? Yeah.
There is a class called like a navigable. The collection is the iterable like similar.
No. So iterable sits at the very base of the inheritance tree. It is even more general than collection. So iterable has only one method called iterator, which will let you get an iterator, and then you have collections, sets, sorted sets, and navigable set is way down here. It's a very large API for dealing with sorted data and navigating it in both directions and finding the head set and the tail set and all kinds of really great stuff. We're really looking forward to supporting navigable set and navigable map in our API, which we will do once we make our big Java 6 transition. Yeah.
One thing that I don't know if it's ever been fixed, but it's always seemed like a really big conundrum to me, which was that anybody in this world could design an interface like set and not have the most basic operations in it like intersection and difference, which I think Rogue Wave does, but the JDK doesn't, and I just never could figure out how anybody could do that. It just puzzles me.
Who can we blame? Who can we lynch?
So, basically, it's one-liners to get those things, right? Remove all and retain all give you precisely that. But you have the choice as to whether you want to do them destructively or non-destructively. So, we gave you slightly more general operations. That said, I acknowledge that, the names are a little harder to understand, and I certainly believe that when you're designing an API, you must understand your audience. You must produce an API that is pleasant to use, and I think perhaps we could have done better there. That said, I think that on balance, we made a lot of good decisions, and I think that the past 11 years have shown that it is an API that has withstood the test of time, albeit it has faults.
And I want to point out that if you want union and intersection and difference methods, we have them in our library. So you can use them. Josh hates them. No,
I don't hate them at all. And in fact, I'm surprised that we didn't have them in collections.
Yeah. It's actually a little non-trivial to decide how to implement them because you don't want to simply choose for the user what type of implementation you're going to put the results into. Because the user might have sorted sets, or you might have linked hash sets, or enum sets, or whatever, and you don't want to just arbitrarily say, we're going to use linked hash set for our result type. So our union and intersection and difference methods are implemented as views. So when you call methods on them, they simply call to the underlying methods, and then there's a method you can say copy into, and then you can tell it exactly what kind of collection you want to copy it into. That's sort of in common throughout our whole library. Is we try never to choose implementation for you unless it's in a method called new hash set. Then we give you a hash set. But instead, we try to return you an iterable and let you copy it into the type that you want it to be, or things like that. This is the slide that I'm going to just skip. This is the stuff we're not telling you about. We're not telling you about all of our forwarding collections, constrained collections, precondition check methods, union, intersection, difference, but we did tell you about those. Multimaps.index and maps.uniqueindex, class-to-instance map, abstract iterator, peaking iterator, and all kinds of other stuff. So that stuff exists too. I'm not telling you about it. And we're just about done, but I wanted to put one slide on here to brag, to tell you about how we test all of this stuff. Because we have over 25,000 unit tests for this library, a fact which I'm very proud of. And we owe this fact to a couple of Googlers. I have their names down there, Chris Poverk and George. And Chris Poverk and George built this framework that basically for every different collection implementation that we have, we sort of use this API to tell it the features that collection has. Does it allow null values? Does it have comparator order or arbitrary order or whatever? And we fill in an interface where we actually create the thing, and we send it off to this thing, and it returns us a JUnit test suite that'll have 115 methods in it, or tests in it. And it's pulling those from, we have these big test files full of all these methods that are annotated, and it matches up these features with the annotations and methods, and it constructs just the right test suite that verifies every last unbelievably nitty-gritty thing about the collection. In fact, there are several JDK collections that do not pass all of our tests, and ours do. Now, this is not to say that JDK collections suck. This is to say that we're talking about really anal retentive little things here. And in every case, there are bugs filed already against the JDK, but it hasn't been super high priority to get them fixed yet. But hopefully that gives you an idea of our level of commitment to really honoring the letter of our specification very, very tightly. And this framework will be open sourced at some point soon. And then if you write your own collections, you can actually use this to test your own collections too. That's it. We finally made it to the end. Andreas?
Yeah, a question about the previous slide.
Yes.
You guys are saying you're being very particular about the test. Why are you using a string literal then?
String literal?
I mean, for named. I mean, why not actually?
Oh, for the name?
Yeah, for the name.
Oh, this name
because for the test, because then that's another place somebody can screw up. I mean, why not?
This right here?
Yeah.
So this is just decoration. This is just so that when your test suite is running, it's showing you what it's doing. That's all.
Okay.
Yeah, and then these things here are actually enums, these general purpose, allows null values and so forth.
Okay, cool.
Okay. Questions?
So is the intention to put this through the JCP at some point?
Do one of you want to answer this, or should I take a crack?
Yes.
There you go. So it's really, the JCP is not necessarily the ideal forum to do real forward-thinking development. It's a lot easier to just develop all this stuff under the auspices of an open source project, get people using it, and then when things look pretty firm and you've battle tested them and you've figured out what things should be named, then the hope is that we'll start a JSR or do whatever process will exist at that time to try to put some of the stuff in the JDK. Martin?
When something goes into the JDK, it's kind of like it's frozen forever, right? Code is really, really, really hard to change once it's in there. So I used to work at Sun, and so when you work at Sun, you have to work. You have to try to get it right the first time, and human beings aren't very good at getting it right the first time. So I think that the model that's being used here, where code is actually being run, it's being used by real people in production, and then you want to put in the JDK. I think that's the right order to do things in.
That brings up a point that I wanted to explain, which is, why is this library being developed at Google and why is it coming from Google? Part of it is because, we have some really, really good people who I've been able to ask all of my questions. I basically typify this expression of standing on the shoulders of giants, because everything I do, I just ask like enough experts and try to put it all together in my head and figure out what to do. But the other part is just we simply have an environment at Google that is very, very conducive to the development of libraries like this. It's really very unique. We have a very aggressive attitude towards sharing code here. If I have like a performance improvement or an API improvement that I want to make to a library, I can get that change made and actually out in production in every Google service on their next push. It's sort of a system. It sounds kind of mind-blowing when you think about it, that I can actually cause changes that don't have to wait for the sign-off of every individual project first. But this situation has led to a really unique ability to write code, get it used, see how it works. If I need to rename something, I literally open up all of the Java code in Google in IntelliJ, and I hit Shift F6, and I modify that code and everybody's client code at the same time. That's literally what I do. So, and together with that, we have no shortage of really wonderful, opinionated engineers who join my mailing lists, and we discuss all of these things. And through, when we get a really heated debate going on, that's when we really know that we're going to hit on something really good out of that. So it's sort of like, I don't know how we could have developed this anywhere else but at Google, and I just wanted to say that. I think you had your hand up first, in the front row.
Yes. So I was going to ask about whether you were influenced by the Apache Jakarta Commons or whatever, but now I want to ask you, when you do those huge global refactorings like rename or whatever, do you find that the next day anybody has changed anything back?
Nope. If they did, their build would break.
Okay. So then maybe the Apache question.
Okay. So we were not really influenced by the Apache library. We were aware that it existed, but because Google adopted Java 5 and generics very early on, it was and we went through and we generified all of our code like really fast. Again, I used IntelliJ. I loaded up a big swath of code and I hit, Alt-Shift F12 or whatever, and it generified all the code. So once we crossed that Rubicon, then generics were very important to us, and there was no officially available generified version of the Apache library at that time. When we noticed that, and we also noticed that the Apache library takes a different approach to us in many ways when it comes to adhering to the letter of the specifications of the interfaces that they implement from the JDK. So we're very, very hardcore about following those interfaces as tightly as we can. And their library, for valid reasons, decides to depart. I don't want to say it's a totally dumb thing to do, but they've chosen to depart from those specifications in certain ways and just try to flag it in their Java doc as saying, violation. We decided that when code implements an interface but it doesn't adhere to the letter of what that interface says, then your code is going to be harder for people to learn. They have more stuff that they have to keep in their head and more edge cases they have to think about. And if you just get religious about it as much as possible, then you've just made everyone's lives easier. So because of that, we just sort of have an independent evolution from that library, and we've never really reviewed that library to get ideas of what to do. Our ideas come directly from what actual Googlers are trying to do in their projects. We look at their code and we say, oh, you had to write 50 lines to do this. Let's write a library that you can use.
This is kind of a two-part question. The first part is, how many people did it take to write those 25,000 unit tests?
So the 25,000 unit tests weren't written by people, right? They're written by this framework that spits them out. right? So in the terms of actual number of test methods that we've written, maybe it's only like 2,000 or something. I don't know. And then it's recombining those in many ways. And it's doing so in such a way that everything gets created as an independent JUnit test case so that when one fails, it doesn't cause a whole huge thing to fail. It just pinpoints exactly what the failures were. And that's what blows those numbers up.
Okay, and the second part of the question was if it takes all this experience and expertise of the world's top Java programmers to write these, what accomplishes this task here, which is really relatively simple, at least on the surface. I mean, we're not doing rocket science here. We're doing the kind of stuff that we learn in, data structures classes and whatnot. Then what chance do the rest of us poor mortals have of writing a bug-free code when we're actually writing a real application that's really complicated, like maybe putting a lander on Mars or something like that?
So the question is, so I've alluded to the difficulty of writing this library, or how much work we've spent on it, and the question is sort of if it was that hard for us to write the library.
Yeah, this is a fairly simple task compared to
which is writing the library.
Yeah, a library is a relatively constrained environment. It's a pretty small task compared to.
I remember when I used to think so.
Right.
That would be before I spent the last 3 years of my life.
But just think of a large application that has really life-threatening consequences, or safety concerns and things like that. Doesn't have the kind of resources even that you can really bear down on such a small. You're using a fairly large amount of resources, at least intellectually, on a fairly small problem, whereas the rest of us a lot of times probably have to deal with a bigger problem with less resources. I'm wondering how we can actually write code that's reliable.
Our approach to the approach that Jared and I and the rest of us who've worked on this have been taking is to try to build up from the bottom level, higher and higher level utilities that do more of the work for you, that cause you to have to write less code, that cause you to have to test less code, and we test the hell out of our things, so that do I want to say that rising tide lifts all boats? I just said it. So that's our angle on trying to make your job easier. Other people are working on possible language changes. Other people work on tools and so forth. We do it through libraries. It's, I kind of want to address the idea that writing the library is easy or simple, because it's not. But I don't know how to describe why, but it's been very challenging. So that's all right. Next question, Josh.
Well, could I just add a little to your previous answer?
Yes, please.
So writing libraries is much harder than it looks. I think the guy who is reputed to have said it best is Thelonious Monk, although he wasn't actually talking about libraries. He said simple ain't easy. He didn't actually say that. It turns out what he really said was them simple chords ain't so easy to play now. But it's the same idea. The thing about a library is if you did it right, it looks and feels incredibly simple. And achieving that turns out to be incredibly difficult. And it's worth it because of the economies of scale. You write these things once, and they're used by millions of people for tens of years. And that's why it's worth putting so much effort into libraries, because you have this tremendous economy of scale, and you can't afford to apply that much effort to the system that you're building. Does that mean you can't make a mission-critical system that works? No, it doesn't mean that. But the thing about your system is it doesn't have millions of programmers who are going to be confronted with actually using those APIs. So if the APIs are a little bit more difficult to use, it's not the end of the world. If his are a little bit more difficult to use, multiply the pain by the millions of programmers who are going to use them over the years that they're going to be using them. And furthermore, if he can make them just a tiny bit faster, they're in people's inner loop. This is inner loop code. So, all the time we talk about don't prematurely optimize. In this case, we actually have to optimize, and it's not premature. We know up front this is inner loop code.
Anyone else?
Time for 2 more questions. I just wanted to get queued up to do the raffle. Just as a segue, though, you mentioned several times about IntelliJ IDEA. The one thing we're raffling off tonight is a free license to IntelliJ IDEA. So
I would be lost without it.
Cool. I just wanted to.
I'm
I
sorry.
don't know what
This
that is.
everyone who registered in advance. When we do the raffle, the spinner is actually written in java.fx.
The list of people who have contributed meaningfully to our project would probably have just about that many names on it, though, although it's a long tail effect. But because of the open sort of development process that we have in the mailing lists, that anyone can join and participate in any of our discussions, and every line of code that we write gets emailed out and discussed to death on these lists. So I can't even properly thank all the people that I should be thanking. But certainly Josh has been our biggest spiritual advisor. And Jared, who may have slipped out, has written. There's Jared. Has written most of the code, and Jesse's been a huge help back there, and some other people at other offices who weren't able to be here. Did I just snub anyone?
I just wanted to make my comment that I very much appreciate your work, especially with the java.util collections library, and I know that you put a lot of work into it, and I use it all the time, and I value it very highly, and this stuff looks fantastic, so thank you.
Thank you.
We should end on that
You wouldn't believe how infrequently people bother to say things like that. So thank you.
Yes, thank you very much, Kevin. So I actually did not do one of the announcements at the beginning. There was someone here from QCon, but they weren't able to stay. So the QCon conference coming up in November, I guess I should have said that my favorite conference locally is in September is is the Rich Web Experience. But my favorite I can't even say that. But it is a good conference. I haven't been to QCon, but I mean, if you look at the speaker list, it's just really impressive. So I have some handouts here that have a promotion code for $100 off. If you think you're at all interested, or if you know someone who might be, please take one. And next meeting, the JUG user meeting on the 18th with Rod Johnson, she'll be coming back since she wasn't able to do it tonight, and we'll be raffling off one free pass to that conference. And it's I don't know what it goes for, but that's at least in excess of $500 conference. So. And besides, it's Rod Johnson, so you got to come back. So let's just do the raffle now for the IntelliJ ID license. You have to be here to win, and so we'll keep going. And if you really won't use it, just say so, and we'll spin again. But you really should use it if you haven't been already. Okay, great.
These will be on the back table if you're interested.
And so we're spinning. Jim Weaver wrote the original code. We tweaked it a little. Actually, Kevin tweaked it a little bit. And the winner is Oswald. Where are you, Oswald? Did he leave? He was here.
Oh, we got to give it to him. Come on.
No, you have to be present to win, even though we know the person.
Oswald's a good guy.
He's actually someone who's been a great supporter of the group, but I'll have to run again. He's going to be bummed. He probably already has a license, actually.
I bet I can get him one anyway.
Go. Steven, are you here, Steven? All right, another long-time regular. Cool. So we'll just have to get your email, and we send you your name and email to them, and then they set you up. Okay, so if you come back on the 18th, we'll have another license. You'll have another 1 in 100 odds chance to win a license to IntelliJ. All right. Thank you. Thank you for coming.